Welcome to our channel, where we embark on an exhilarating journey through the world of mechanical engineering. In this video, we will delve deep into the fascinating realm of mechanical engineering, exploring its essence, the foundational principles that underpin it, the diverse branches it encompasses, the exciting career opportunities it offers, the skills required for success, and the average salaries that await aspiring mechanical engineers. So, fasten your seatbelts and let's dive in. What is mechanical engineering? Mechanical engineering is a captivating discipline that blends the principles of physics, mathematics, and materials science to design, analyze, and manufacture a wide array of mechanical systems. It is a driving force behind innovation and progress, shaping the world we live in. But what exactly is mechanical engineering, and how does it impact our lives? Foundations in mechanical engineering. To truly understand the world of mechanical engineering, let's explore the core principles that underpin this dynamic discipline. These principles serve as the fundamental pillars upon which mechanical engineers design, analyze, and innovate. Mechanics. Mechanics is the branch of physics that deals with the study of forces and motion. It enables engineers to understand how objects move and interact under different conditions, allowing them to design and analyze mechanical systems. Thermodynamics. Thermodynamics focuses on the study of energy and its transformation. It provides engineers with the tools to analyze and optimize energy systems, ensuring efficient utilization and minimizing energy loss. Fluid mechanics. Fluid mechanics investigates the behavior of fluids, liquids and gases, and their interactions with solid objects. It is crucial for designing systems that involve fluid flow, such as pumps, turbines, and piping networks. Materials science and engineering. Materials science explores the properties, behavior, and selection of materials for engineering applications. It helps mechanical engineers choose appropriate materials based on their mechanical, thermal, and chemical properties. Control systems. Control systems involve the design and implementation of mechanisms that regulate and automate mechanical processes. Engineers use control systems to ensure desired performance, stability, and reliability in various applications. Solid mechanics. Solid mechanics focuses on the behavior of solid materials under external forces. It encompasses concepts like stress, strain, elasticity, and deformation, enabling engineers to design structures and components that can withstand loads and forces. Dynamics. Dynamics deals with the study of motion and the forces causing it. It enables mechanical engineers to analyze the behavior of moving objects and systems, helping them design mechanisms and optimize performance. Kinematics. Kinematics is the study of motion without considering the forces causing it. It provides mechanical engineers with the tools to analyze the motion and behavior of mechanisms and systems, aiding in the design process. Machine design. Machine design involves the creation of new or improved machines and mechanical systems. It encompasses the selection of components, consideration of forces and loads, and the integration of various mechanical elements. Manufacturing processes. Manufacturing processes encompass various techniques used to transform raw materials into finished products. Mechanical engineers need to understand these processes to design components that can be efficiently manufactured. By mastering these core principles, mechanical engineers gain a solid foundation and the necessary knowledge to tackle complex engineering challenges. These principles serve as the bedrock of mechanical engineering, allowing engineers to innovate, design, and optimize mechanical systems that shape our modern world. Branches of mechanical engineering. Mechanical engineering encompasses various branches that specialize in different aspects of the field. Let's explore some of these branches and understand their unique focuses and applications. Robotics and automation. Robotics and automation involve the design, development, and operation of robotic systems and automated machinery. This branch combines elements of mechanical engineering, electrical engineering, and computer science to create intelligent machines that can perform tasks autonomously or with minimal human intervention. Robotics and automation find applications in industries such as manufacturing, healthcare, and space exploration. Automotive engineering. Automotive engineering focuses on the design, development, and manufacturing of automobiles and their components. This branch involves optimizing vehicle performance, fuel efficiency, safety, and ergonomics. Automotive engineers work on various aspects, including powertrain systems, vehicle dynamics, aerodynamics, and vehicle electronics. They contribute to the advancement of automotive technologies and the development of sustainable transportation solutions. Aerospace engineering. Aerospace engineering deals with the design, development, and production of aircraft and spacecraft. This branch encompasses aerodynamics, propulsion systems, material selection, and structural design to ensure safe and efficient flight. Aerospace engineers work on projects ranging from commercial airplanes to satellites, exploring innovative solutions to enhance performance, reduce fuel consumption, and improve safety in the aerospace industry. Energy systems. Energy systems engineering focuses on the design and optimization of energy generation, distribution, and utilization systems. Mechanical engineers in this branch work on renewable energy technologies, power plants, energy storage systems, and energy-efficient systems for buildings and industries. They contribute to the development of sustainable energy solutions to address the global demand for clean and efficient power. HVAC and refrigeration. HVAC, heating, ventilation, and air conditioning, and refrigeration engineering involve designing systems that control temperature, humidity, and air quality in buildings and vehicles. Mechanical engineers in this branch work on the design and optimization of heating, cooling, and ventilation systems to provide comfort and energy efficiency. They also contribute to refrigeration technologies used in food preservation, medical applications, and industrial processes. Marine engineering. Marine engineering focuses on the design, construction, and maintenance of marine vessels and offshore structures. This branch involves working on ships, submarines, offshore platforms, and coastal infrastructure. Marine engineers deal with aspects such as hydrodynamics, propulsion systems, stability, and marine structure design, ensuring the safe and efficient operation of marine systems. Biomechanical engineering. Biomechanical engineering applies mechanical engineering principles to study and improve biological systems and develop medical devices. Mechanical engineers in this field work on areas such as prosthetics, orthopedics, rehabilitation engineering, and biomaterials. They contribute to advancements in healthcare by designing devices that enhance mobility, restore function, and improve the quality of life for individuals with physical impairments. Mechatronics. Mechatronics combines mechanical engineering, electronics, and computer science to design and control intelligent systems. This branch focuses on integrating mechanical components with sensors, actuators, and microcontrollers to create smart and automated systems. Mechatronics engineers work on applications such as robotics, industrial automation, autonomous vehicles, and advanced manufacturing processes. These branches represent just a fraction of the diverse fields within mechanical engineering. Each branch offers exciting opportunities to specialize in specific areas and contribute to advancements in technology, transportation, energy, healthcare, and more. Careers in mechanical engineering. Mechanical engineering offers a wide range of career opportunities across various industries. Let's explore some of the exciting career paths that mechanical engineers can pursue. Design engineer, research and development engineer, project engineer, manufacturing engineer, quality assurance engineer, energy engineer, HVAC engineer, automotive engineer, aerospace engineer, consulting engineer. These are just a few examples of the many exciting career paths available to mechanical engineers. With their strong foundation in core principles and the ability to apply their skills across different industries, mechanical engineers are well positioned to make a significant impact and shape the future of technology and innovation. Opportunities and skills in mechanical engineering. In addition to the diverse career paths we discussed earlier, mechanical engineering offers a plethora of opportunities for growth and development. Let's explore some of these opportunities and the essential skills that are highly valued in the field. Research and development. R&D mechanical engineers have the opportunity to work in research and development, where they can contribute to groundbreaking innovations and technological advancements. R&D positions allow engineers to explore new concepts, conduct experiments, and develop novel solutions to complex engineering problems. This involvement in research enables mechanical engineers to make significant contributions to the advancement of technology and drive innovation in various industries. Project management. Mechanical engineers often find themselves in project management roles, overseeing the planning, execution, and successful completion of engineering projects. Project management skills, including scheduling, budgeting, resource allocation, and team coordination, are essential for effectively managing complex engineering projects. These skills allow mechanical engineers to ensure project objectives are met within the given constraints of time, budget, and quality. Sustainable design and renewable energy. With the growing focus on sustainability and environmental consciousness, mechanical engineers have ample opportunities to contribute to sustainable design and renewable energy projects. They can work on developing energy-efficient systems, optimizing energy consumption, and integrating renewable energy sources into various applications. By leveraging their expertise, mechanical engineers play a vital role in addressing global challenges related to climate change and creating a more sustainable future. Advanced Manufacturing and Industry 4.0. The advent of advanced manufacturing technologies, such as additive manufacturing, 3D printing, robotics, and automation, presents exciting opportunities for mechanical engineers. They can contribute to the implementation and optimization of these technologies, enhancing manufacturing processes, improving product quality, and increasing production efficiency. Understanding the principles and applications of Industry 4.0, which integrates digital technologies with manufacturing, enables mechanical engineers to thrive in the evolving manufacturing landscape. Entrepreneurship and startups. Mechanical engineering provides a strong foundation for entrepreneurial endeavors. Engineers can leverage their knowledge and skills to identify market gaps, develop innovative products or services, and launch their own startups. Entrepreneurship allows mechanical engineers to bring their ideas to life, create job opportunities, and make a significant impact in their chosen industry. Cross-disciplinary collaboration. Mechanical engineering often involves collaborating with professionals from diverse disciplines. Mechanical engineers work alongside electrical engineers, computer scientists, materials scientists, and other experts to develop multidisciplinary solutions. Strong collaboration and communication skills are vital for effectively working in teams, integrating different perspectives, and creating comprehensive engineering solutions. Lifelong learning. Mechanical engineering is a continuously evolving field, with new technologies, techniques, and industry practices emerging regularly. Therefore, a commitment to lifelong learning is crucial for staying updated with the latest advancements in the field. Engaging in professional development activities, attending conferences and seminars, and pursuing additional certifications or advanced degrees help mechanical engineers enhance their knowledge and skills, making them more valuable in the job market. By cultivating these skills and embracing the various opportunities available in mechanical engineering, professionals in the field can enjoy a fulfilling and successful career. Average salary and outlook. Now, let's talk about the financial rewards and future prospects for mechanical engineers. The average salary varies depending on factors such as experience, location, and specialization. However, mechanical engineers generally enjoy competitive salaries and promising career growth. According to recent data, the average annual salary for mechanical engineers ranges from $70,000 to $110,000. And that wraps up our captivating exploration of mechanical engineering. We hope this journey has ignited your passion for this incredible field, inspired your career aspirations, and provided valuable insights into the foundations, branches, career opportunities, skills, and salaries associated with mechanical engineering. If you have any questions or would like us to cover specific topics in future videos, please leave a comment below. Don't forget to subscribe to Mechanical Lab YouTube channel for more exhilarating content on engineering. Thank you for joining us, and until next time, keep pushing the boundaries of mechanical innovation.